Jimmy, if you weren't here, we did a couple of problems right here. We did number 4 from the homework. If you want to pause and look at that, you can. Here is number 8 on. Okay, so that was number 4 on your homework. This is number 8 on your homework. We did it by factoring and quadratic formula. You just have to do it one way. And we're doing number 9 now. Okay, you guys, number 9. Number 9, right here. If you notice, 2 times 4, 1 times 8, we're making them both negative, like negative 2 times negative 4, negative 1 times negative 8, are the only possibilities of numbers you can multiply together and get 8. Well, if you notice, none of them is going to add up to 12, right? Because this coefficient's 1 over here. So none of them are going to add up to 12. So you know right away, you can't do it by factoring, okay? So I'm going to use either, and I'll tell you what, when the coefficient's 1 and this is an even number, completing the square is a really easy method. Okay, so I'm going to show you by completing the square. Did anybody do it by completing the square? Okay, good, Roger. And to do that, you guys, in this case, when you're completing the square, this is the one time you don't have to set it equal to 0. You get the constant on the other side, right? Okay, so, but if you're going to use the quadratic formula or factoring, you've got to do it the other way, okay? So now, I'm looking for the number I can complete the square with. I take half this number and square it. What's half this number? Squared is. So if I add 36 to this side, I have to add 36 to the other side, right? This factors. What two numbers can I times together and get positive 36? Add together and get negative 12. Negative 6 and negative 6, right? So x minus 6 times x minus 6, which I write the short way as x minus 6 squared. Negative 8 plus 36 is 28. Okay? Now, this one's fairly easy to solve using the quadratic formula because I just take the square root of both sides. I get x minus 6 equals plus or minus the square root of 28. Now, 28 is not a perfect square, is it? So we actually did this one the other day in class. What does 28 break down to? 4 times 7 and 2 times 2 times. So we got a pair of 2's and a loner 7. So what is it going to be? 2 root 7. So we have x minus 6 equals plus or minus 2 root 7. That's what square root of 28 is 2 root 7. Add 6 to both sides, and I get x equals 6 plus or minus 2 root 7. And that is your answer. If you use the quadratic formula, you're going to get the same answer. Okay? I only would suggest using completing the square under what two conditions did I say? A is 1 and B is an even number. Yep. Yeah, you don't, if you do it when it's odd, then you have fractions, right? That's the only time I would suggest using completing the square because it would be faster to do everything the other way. Okay? Hey, by the way, 6 plus 2 square root 7 is going to be somewhere around 14 or 15, isn't it? Someone go 6 plus 2 times the square root of 7 in your calculator for me. What is it going to be? Roger, you got it? 6 plus 2 root 7? 11? That can't be right because you got, oh wait, no, yeah, that could be right. Yeah, that could be right. 11 point what? 29. And go 6 minus 2 root 7. 0.708. So there's your two answers as irrational numbers. Which way do I want it? I want this one right here that still has a square root in it, okay? When we come back from Christmas, we'll learn this right here. We'll learn about irrational numbers more. Okay. That's 9 on your assignment. Okay, everybody go to number 11, 12, and 13. Okay. Doesn't it ask when is it, what does it ask on this exactly? What's the instructions? Okay, summarize the process. Okay, so if we were to summarize the process of completing the square, what are we going to do first? Step 1. Okay, well, actually, not on completing the square. This is that one exception. So get the constant to the other side of the equation, right? Get constant to right side. You guys, I'm not going to stay on this slide forever, so if you're going to do this one, write it down. Number 2, what's the next step? What do we do next? Okay, well, we got to complete the square, don't we? Complete the square. So do you do, okay, so you complete the square by dividing the middle term by 2 and squaring it, right? So complete the square. I'm just going to leave it at that, because you guys know to complete the square, you take half of b and square it, right? That's what it means. If you want to take half of b and square it by it, you can. Okay, what's the third step? If we go back up to this problem, what was the third step we did? Put it in factored form, x minus 6 squared, right? Okay. Put in factored form. So in this form, x minus b squared, right? Equals c. Okay? What's the next step? Square root both sides? Square root both sides. And step 5, add b to both sides, right? Add or get b to the right side. Get b to the right side. What I mean by that is right here we added 6 to the other side, right? Okay, that's how you complete the square. When is it best to do that? When is it most efficient? A is 1, B is even. Okay? Write that down. When A is 1 and B is even. That's when it's best to do that. Honestly, I very rarely use that method. I always either use factoring or the quadratic formula. That's all you need to know. Okay? Okay, factoring. Okay? Step 1, put into 2 binomials. So you have something like x minus r times x plus t equals 0, right? In step 2, set each binomial factor equal to 0. Okay, and solve. Step 3, solve. Okay? Solve for x. Yeah. Solve for x. Okay? When is it best to use factoring? When it can be factored. When it can be factored, yeah, when it works. Okay, I prefer, you know what? If I get really big coefficients for A, if I get a really big coefficient for A, I just use the quadratic formula. I don't even try to see if it can be factored because it'd take forever. I just use the quadratic formula. Okay? So it's only if, I usually like to, if A is 1 and it's factorable, I'll factor it. Or if A is a small number like 2 or 3, then I'll factor it if I think it's factorable. Okay? Okay, quadratic formula. Step 1, put A, B, and C into x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I never made you guys sing the song, did I? We're going to sing the song one time. We got to do it one time. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, you guys ready? 1, 2. You guys got to sing. We're not moving on until we all sing, until Grant sings. 1, 2, ready, sing. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Justine's giving me a dirty look right now. She never sang it. We're going to sing it again. This is for Justine. If Justine doesn't sing, we're going to sing it again after that, okay? You're going to ready to sing, Justine? All right. I'm going to turn this. Okay, you guys, number 15. 14 and 15 are similar. All right, you guys, f of x equals x squared minus 4x minus 1. We got to do several things. Number one is it says to graph it. You know what I would do right here, you guys? I would put it in my calculator right here. Everybody, go graph that in your calculator right now. Please listen. Okay, right here, I'm looking at this. The only reason I want you to graph it on here first is because I want you to get an idea of where everything is. Remember, your line of symmetry is the line that goes right through here. It's pretty close to 2, but I don't think it's right on 2. I could be wrong. It looks like my x-intercepts are, I think it's a little bit more than 4, but it could be right on 4. I think it's a little less than, 0. Okay? That's what I'm looking at. So when I go to do this, and notice my vertex is somewhere around 2, negative 5. So this is what we're going to do, you guys. According to my, and it almost looks like 0, negative 1 is my y-intercept, which I know for sure that's it, because I can just look at the equation and get that. But my x-intercepts look pretty close to 0 and 4, but it doesn't mean that's what necessarily is. So that gives us an idea. So now we're going to go back to this, and we've got to do it algebraically, most of it. Okay? Just a reminder, how do you find a y-intercept? Put 0 in for x. Everybody, if you haven't written that down on your 3x5 card in your notes, or you don't know it, then I write it down. I've told you several times, to find the y-intercept, you put 0 in for x. So if I put 0 in for x, in other words, if I do f of 0, 0 squared minus 4 times 0 minus 1 equals negative 1. So I know my y-intercept's at 0, negative 1. I'm going to put that right there on my graph. Okay? That's an easy point to get. This one would be a really easy one to put in vertex form, because A is 1, B is even, right? So let's do that next. Let's put this in vertex form. This is completing the square like we did. X squared minus 4x. But this time I'm going to leave the minus 1 outside. Now notice, since we're not completing the square to solve an equation, we leave the minus 1 on the same side of the equation. I take half of 4 and square it. What's half of 4? 2 squared is 4. So I'm adding 4, and since it's on the same side equation, you guys, I got a minus 4. Do you understand this? The difference between putting something in vertex form and solving the equation by completing the square? They're both completing the square, but this one we're solving, or writing in vertex form. Factor this. What two numbers can I times together and get 4 and add together and get negative 4? Negative 2, right? X minus 2 and x minus 2. And negative 1 minus 4 is negative 5. So guess what? my vertex is at 2, negative 5. Remember, it's the opposite of this. X minus 2 would be positive 2, negative 5. So my vertex really is right at 2, negative 5. And we checked that on the thing. So we're going to go over to 2 and down 1, 2, 3, 4, 5. It didn't look like it was right on there to me. Now, I do know that the x-intercepts are not 0 and 4 because I can see right now that this thing does not factor because there's not two numbers you can times together and get negative 1, add together and get negative 4. So there is no x-intercept. But this is why completing the square is kind of nice. Since I've already found the vertex, I put this in vertex form, all I have to do is replace f of x with 0. And I can solve this equation to get my two x-intercepts. Do you see that? That makes it pretty nice. So what am I going to do to solve this? Add 5 to both sides. What am I going to do next? Square root both sides, right? So I get x minus 2 equals plus or minus the square root of 5. What's the last thing I got to do? Add 2. So x equals 2 plus or minus the square root of 5. There's my two x-intercepts. Now, could you use the quadratic formula? Yes, you can always use the quadratic formula to get x-intercepts on a quadratic equation. You can always use that method. You can always use completing the square. No, the y-intercept, you just put 0 in for x. It's always going to be this number right here, right? Okay, now, I want everybody to put in their calculator. Alex, please don't talk. 2 plus the square root of 5. 2 plus the square root of 5 in your calculator. Someone tell me what it is. 2 plus the square root of 5 in your calculator. What is it? 4.2? So x equals about 4.2 is one of my x-intercepts. And now go 2 minus the square root of 5. Negative. Is it, yeah, negative? Negative 0.2. Okay. Now, you guys, since my vertex is at 2, negative 5, I know my line of symmetry is x equals 2, because it's always x equals the x coordinate, right? So I've got that one done. This is stuff we've done before, isn't it? This was on last test. So we got that down. So, okay, any questions on that? What about 18 and 19? I'm going to go, I've got some problems written down here. I can't remember what numbers they are, but let me look at these two. Which two I got? I got 17 and 19. Let me just show you, and then you'll know how to do it. Okay? All right. Hey, you guys. 17 you guys learned how to do last year. Okay? Now, you can either use substitution or elimination method. Do you remember that? However, I need all eyes right here, you guys. Can't be talking right now. You got to hear this part, okay? You can use substitution or elimination, but since it's already, both of them are solved for y, substitution is by far the easiest way to do it. Because if this is equal to y and this is equal to y, and we know y is equal to each other, we know negative 7x plus 12 is equal to 5x minus 36. Because they're both equal to y, so they have to be equal to each other, right? And you know how to solve an equation like this. I can add 7x to both sides and add 36 to both sides. That adds up to 0. That adds up to 48. That adds up to 12x. That adds up to 0. So what's the last thing I need to do to solve this equation? Divide by 12. And what do I get? X equals 4. Okay? So that's x. How do I find y? I can plug it in for either equation and for x. I like the bottom equation a little bit better. So I'm going to go y equals 5 times 4 is 20 minus 36 equals negative 16. So 4 comma negative 16 is the solution to that problem. Okay, do you remember that method? from last year? Okay, that's the substitution method. Now, I would suggest, do we have this down? I got x equals 4, so I put 4 in for x. 5 times 4 is 20. Minus 36 equals negative 16. Okay, last problem. That one what? Well, let me see 18. Let me see 18. Oh, yeah, I did one of each kind just on purpose. Okay, you guys, if you know how to do 19, you'll be able to do 18, Shaden. Okay. All right. If you know how to do 19, which I'm going to show you right now, you'll be able to do 18. Okay. Look, once again, they're both equal to y. So what can I do? Actually, I'm going to do it this other way around. I'm going to go 8x plus 48 equals what? Okay, good. Those two are equal to each other because they're both equal to y. By the way, you can look at this right now, you guys. What kind of equation is this? Quadratic. All you have to do is set it equal to 0 and use a quadratic formula or factor it or complete the square. Okay? So what you're going to do is I'm going to add x squared to both sides. And I'm going to minus 24x to both sides. Now, those two add up to 0 over there, right? And over here I get x squared. 8 minus 24 is a negative 16x plus 48 equals 0. I've got a quadratic equation. I just got to solve that. And I'm guessing, you guys, that factors. I can see two numbers I can times together and get 48 and add them together and get negative 16. 6 and 2? 6 and 2 don't. 6 times 2 is not 48. 6 plus 8 is 14. She's got it. 12 and 4. But what do they both have to be? What do they both have to be? Negative. They got to both be negative. So x equals 12 and x equals positive 4 are your two solutions. Now that just gives us x. We got to go find y. Because there's more than one solution. With quadratics, you got two solutions, right? So let's plug in 4 first of all. Well, you guys, what we're looking for is the x-intercepts, right? Whenever you solve a quadratic equation, you're looking for the x-intercepts, and so it's got two values. But well, there's two equations right here. What it is, you guys, is we have a line, and you have a line and a parabola, and your line and parabola twice, and so there's going to be two solutions. A solution to a system of equations is where they intersect each other. So if I plug 4 in for x, y equals 8 times 4 plus 48. 8 times 4 is 32, plus 48 is 80. So one of my answers is 4, 80. Okay, if I plug 12 in for 8, 8 times 12 is, what's 8 times 12, you guys? 96. Plus 48. Isn't it 144? 12, 144 is your other solution. It doesn't matter. I plugged them both into the bottom one. If you plug them both in the top one, you get the same answer. You plug one in one and one in the other, you still get the same answers. Because what this is a system of equations. We found the numbers that would make both equations true at the same time. And so it doesn't matter which one you plug it into. Okay, that's... Okay, you guys, on lesson 3.8, Simon 3.8. I'm going to do one problem, 1 through 6. I'm going to do, actually, number 6. How's that sound? Square root of 80. We've done these before. You guys know how to simplify radicals, but this is just a chance to practice. I break it down into its prime factors. What's two numbers I can times together and get 80? 10 and 8? I like 10 and 8. How about 10? 2 and 5. How about 8? 4 and 2. How about? Okay, so I've got every one of these numbers. 2, 5, 2, 2, and 2 are all prime factors, right? Okay, Christian. Okay, I've got a pair of 5s right here, a pair of 2s right here, a loner 5, and a pair of 2s right there, right? What do I do? What do I do with my pairs? I take one out of this pair, put it outside. One out of this pair, put it outside. And I put my loners back inside. Now, any numbers outside I multiply together. Any numbers inside I multiply together. And I got my solution, right? 2 times 2 is 4 root 5. I don't know if you guys notice this. Another way that breaks down is 16 times 5 is 80. What's the square root of 16? 4. So 4 square root 5. Do you see that? It's another way of looking at it. You can break square root of 80 into square root of 16 times square root of 5. This is the way I used to teach it. I used to tell the students, go down the list of perfect squares and see which is the biggest one that goes into it. I'd start with 4. Does 4 go into it? Yeah, but let's see if there's a big one. 9. Actually, I'd start the other way. We knew it can't be bigger than 80, so it can't be 81, but 64, there's no way 64 goes into it. 49 doesn't, 36 doesn't, 25 doesn't, 16 does. Check it, 16 goes into it 5 times. So square root of 16 times square root of 5. We know square root of 16 is 4, so it breaks down to 4 root 5. Which way do you guys like better? How many of you guys like the first method better? How many of you guys like the second method better? When it's a number less than 150, I like this method because I can do perfect squares pretty fast in my head. But when it's bigger than that, I like to use this method. Yeah, there's a pair of 2's here and a pair of 2's here. See, 2 times 2 is 4, and the square root of 4 is 2, right?
Will you do that second way again?
Okay, what I do is I know I got to get the square root of 80, right?
Yeah.
So I look at my perfect squares. 81 is one of my perfect squares, but 80, that's bigger than it, so I got to start smaller than 81. 64, there's no way, 64 is almost 80, so it's not going to go into it. 49 is more than half of 80, so it's not going to go into it. 36 times 36 plus 36 is 72, so it won't go into it. 25 will go into 75, but not 80. 16 will go into it 5 times. 16 times 5 is, so the 16 is the biggest perfect square that goes into 80.
So how do you know that 16 will go into that?
Well, because I've been doing math for a long time.
Okay, so I would have no idea.
No, you take your calculator and go 80 divided by 16 and check to see if it does.
So what number you think would go in?
Yeah, I would check. I mean, can you tell that 64 right off doesn't go in? Into 80? Does 64 go into 80? Well, it's way more than half, right? You know what half of 80 is? 40. So there's no way 64 is going to go into 80, right? 49 is more than half, so it's not going to go into 80.
Why do you pick 49?
Huh? No, I'm just, see my perfect squares? 1, 4, 9, 16, 25, 36, 49, 64. I just choose those numbers and see if they go in there. I find the biggest one of those that goes into it.
Why do you skip from 49?
No, 49. You're probably looking at the wrong numbers.
There's not a square root that goes into the...
See the first column of purple numbers?
Yeah.
The second column right there of purple numbers right there. 1, 4, 9, 6, 25, 36, 49, 64. You see those numbers? Those are my perfect squares. Those are the numbers I'm checking to see if go into it. 1, 4, 9, 16. See the column? No. Those are way too big. Okay. All right. What if what?
So like 16 can be squared root into 4. What if there's all the multiples of the number in the square root? What if
One of it isn't, then it doesn't simplify.
then it won't simplify at all?
Like let's say, square root of 30. 30 breaks down to 6 times 5, right? 6 breaks down to 2 times 3. Loner, loner, loner. There's no pairs. So it's square root of 30 is simplified. Yeah. Is that what you're talking about?
So in order to simplify it, something has to be equal to
You have to have 2 prime factors that are the same. See, these are all by themselves. There's none that are the same. They have to either be 2 2s, 2 3s, 2 5s.
But if it gives us prime,
Like which number?
well, not prime number, but what if it gives us like a number like or something like that?
Then it asks you to simplify it? Yeah.
So now you can't.
I mean, you can write. It's already simplified if you want. Okay? Okay. Guys, let's go to number 8 or 9. Which one do you guys want to do? And integers, they usually use Z. Whole numbers, they use W. And natural numbers, they usually use N. It's not written on here. Okay? Mathematicians. They're mostly, hey, Jacoy, they're mostly already dead. Sorry. So. All right. Math lives on. Math lives on. Mathematicians are dead, but math lives on. All right. Hey, by the way, there's more mathematicians today than there ever has been in the history of the world. I would not be considered a mathematician. A mathematician is somebody who discovered math and published it.
Okay. I'm not.
So a mathematician is someone that publishes new math, ideas about math. Huh? Yeah. Guys, if you think about in history, did you know that they're inventing every day? Listen, please. Every day there's new math invented. But obviously in our schools we don't teach all that. But there are, a professor in a college, their job, most professors in colleges, their job is not to teach. Their job is to do research. So a professor of mathematics at a major university, they might teach 1 class or 2 classes a semester, but most of the time is spent researching. And what they do is they study new theories on math and they publish them. Sometimes they publish things saying, hey, we asked this question and we either proved it right or wrong, and that's what they do for a living. No, they probably sit at their desk and do it. They also sit at computers and let the computers know. Reason why mathematics is there's so many new mathematicians is because of computers, because you can do more now because of computers used to be able to do. So mathematician would be somebody who actually invented math, discovered math, and has gone further. I have to say this about me, you guys. I have discovered math that I'd never learned before, but I always think, it's probably been discovered by someone else and they probably published it. But I've had students in my class come up with ideas that I never thought of before. And I said, man, we ought to research this and see if it's been published before, because I've had students come up with some pretty good ideas before. Probably not millions, not in math, but I mean, if you came up with a really novel idea, like the guy who came up with fractals, the guy's probably a multimillionaire. I don't know. Huh? So, you guys, I want to give you some examples of these. Okay? So, real numbers, you guys, real numbers are any number on a number line. Okay? Numbers on a number line. Now, think about this. You guys can put any number, real number, on a number line. You can put 0.34586 on a number line, right? You can put 10 million on a number line. You can put 10.3821 on a number line. Any number that you guys have ever learned about is a real number. We're going to be learning about imaginary numbers soon, which are actual numbers, but it's a different number system. Okay? Now, a rational number, well, I got to talk about integers first, you guys. Integers. Integers are these numbers right here. Okay, guys, these are integers. Alex, shh. These are integers. Okay? It continues that pattern forever. It's the whole numbers and their opposites. Okay? Whole numbers and their opposites, if you want to put it that way. Okay? A rational number is equal to an integer divided by an integer. For example, 5 over 8 is an irrational number because you have integer of 5 divided by the integer of 8. Rational. Okay? Irrational numbers. And by the way, think of 2/3, you guys. 2/3 is 0.6 repeating, right? Irrational numbers have decimals that go forever. Without repeating a pattern. You never repeat a pattern with irrational numbers. So square root of 5, if you put that in your calculator, you're going to get a decimal. It goes on forever. Anytime you take a square root of a number that's not a perfect square, it's going to be an irrational number. Pi is an irrational number because 3.14159 ... It goes on forever without repeating a pattern. Okay? Square root of 7 is an irrational number. Okay? Now, you guys, whole numbers. Whole numbers start at 0 and they're the integers. They start at 0 and go up. So whole numbers start at 0 and go up. Natural numbers, start at 1 and go up. Sometimes they're referred to as the counting numbers. When you start counting, you usually start at 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? The most important ones you can know about are integers, rational, and irrational. Those are the numbers that you really need to understand. Now, for purposes of this assignment right here, when there is not a real number answer, you're just going to put not real. We'll teach you about imaginary numbers later. Okay? So on question number 8, it says, given the quadratic function, this graph, or other information below, determine the nature of the x-intercepts. What type of number is it? Explain or show how you know it. So number 8. You guys, what are the x-intercepts here? They're integers, both of them. What are they? -2 and +3, because it crosses at -2 and +3. Everybody write that down. These are two easy problems. -2 and +3. And they are integers. 3 is also a whole number, right? But don't worry about writing that. Just write an integer. Okay, number 9. Determine the nature of the x-intercepts in number 9. What are they? What are they? Not real, because it doesn't cross the x-axis. Just put not real. Turn it over. Number 10, determine the x-intercepts on this one. X squared plus 4x minus 24. What would you do? I would I'd use the quadratic formula because it doesn't factor. Wait, yeah, it doesn't factor. Well, 4 times 6 is not a difference of 4. 8 times 3 is not a difference of 4, so it doesn't factor, so you got to use a quadratic formula to determine the x-intercepts on number 10. Okay, number 11. You've got two factors. All you have to do is set each factor equal to 0 and solve to get those. Negative 4 and positive 6? Well, negative 4 plus positive 6 is a positive 2. And the middle term is 4. So you got to use the quadratic formula. Hey guys, number 11. Everybody look at number 11. All you have to do is set 2x minus 1 equal to 0 and 5x plus 2 equal to 0 and solve those. Write that down. 2x minus 1 equals 0. Write those down. 2x minus 1 equals 0 and 5x plus 2 equals 0 because it's in factored form. Look at number 12. What are the x-intercepts there? 1 and probably about negative 2 and 1/2, right? So I would say they're rational because they could be written as, negative 2 1/2 can be written as negative 5 over 2, right? Look at 13. What's the answer on 13? Not real. What's the answer on number 14? Or what would you do? You can use the quadratic formula number 14, but it sure would be really easy to factor it. Hey, Cheatin. Those two numbers you can times together and get 16. Come on. 4 times 4 is 16, right? In this case, they have to add up to negative 8, so it's going to be negative 4 and negative 4. So t minus 4 times t minus 4.
Wait, what is 12?
Well, it crosses through 1, so 1's one of them, and negative 2.5. But that's the same thing as negative 5 over 2. Negative 5 divided by 2 is 2.5, right? So negative 5/2. So they're rational numbers, because rational numbers are an integer divided by an integer. Negative 5 divided by positive 2 is an integer divided by an integer. Yeah. So, well, yeah, you got an integer. 1's an integer. Well, 1 is an integer. It's also a rational number. Well, I don't want to worry about that. Write the most specific. So the one on the left is rational, and the one on the right is integer. No, probably not. I need you to understand. This will help you understand it more in depth. Does it help you understand x and?
Yeah, no, but I have questions for you.
I don't know yet. I haven't written it yet.
If you do, like, do you want, like, what Miss Alfred she did, like, in the conversation, it's 6 to 4, 4, 4, 4. Then she had, like, two choices, which one do you want? That's circle.
Okay, number 14. Number 15, determine the nature of the x-intercepts. I'd probably use the quadratic formula on that one. On 15. Huh? Negative on which one? Yeah. But that's just the factors, t minus 4 and t minus 4, so they're going to be 4. But you only need to list it once. 4. So the same thing. Determine the nature of the x-intercepts, whether they're going to be rational, irrational, integers, or not real. You don't understand how to find what, Brian? Say that again. Say that again. Irrational are real numbers, but they're the decimals that go on forever. Like, so if they go through some random, not real, it means like number 13. Look at number 13. It doesn't cross the x-axis. So there's no real solutions to that one. So if they cross through at 1.23458, then it's irrational.
Wait, so do you put the x numbers as irrational?
Say that again?
You want to shred the x-intercepts? You got it?
Yeah. Hey, you guys, listen. Hey, I'm going to give you answers to 16, 17, 18. But I'm not going to do it until you quit talking. Okay, you guys, 16, 17, and 18. This is actually an introduction to stuff we're going to do next year, but it will help you understand quadratics right now. It says determine the number of roots that each polynomial will have. Well, if you look at 16, it says x to the fifth plus 7x cubed minus x squared plus 4x minus 21. Does anybody have a guess at that? How many answers are going to be? Maddie. There are no like terms right there. In 16. Christian said it's 5. Why, Christian? Hey, all it is, you guys, all it is, the highest power. What's the highest power in number 16? So there are 5 roots because it's 5. That's why a linear equation, it's x to the 1 power, it only has 1 root. And a quadratic has x squared, has 2 roots. Okay? And x to the 5th has 3 roots. How many does 17 have? 3. How many does 18 have? 7. You're done with 16, 17, 18. Okay, I'm going to do one of those. Hey, you guys. I'm going to do 25 and 27. We got to hurry. Bell's going to ring here. 25. G of x equals x squared minus 3x. Hey, I'm going to put one like this on the test. It says, given the quadratic function can be factored, then factor and provide the x-intercepts. If you cannot factor the function, then use the quadratic formula to find the x-intercepts. So, you guys, anytime you have the x squared, the x, and the 0 term, and constant is 0, you can factor out a greatest common factor of x. If I take an x out of there, I'm left with x. If I take an x out of there, I'm left with 3. It factors to be x times x minus 3. If I set each factor equal to 0 and solve it, that one's already solved. This one I just have to add 3. There's my 2 x-intercepts, done by factoring. If you take out a greatest common factor, they both have an x in it, both terms, right? You guys, look. It's undistributing. See? If I go x times x, what do I get? X squared. If I go x times negative 3, I get negative 3x. I just took an x out. I undistributed it. You could put that into your quadratic formula. A would be 1, B would be negative 3, C would be 0. You could do that on the quadratic formula, but why? It's too easy this way. You guys are the first ones I ever heard say quadratic formula is so much easier than factoring that. No, I'll let you do whatever form you want to do it in. Okay, you guys, number 27. 27, k of x equals 3x squared minus 11. This one, if you put 0 in for k of x, because that's what you do when you solve, anytime the middle term, the b, is missing, you can just solve it by adding the constant to the other side. So 11 equals 3x squared, dividing by 3. So 11 thirds equals x squared, and taking the square root of both sides. So x equals plus or minus the square root of 11 thirds is your answer. Anytime b is missing, you can just solve it straight out. When you have a, b, and c, you have to do either the quadratic formula or factoring or some method. Okay? But when you're missing either the last term or the second last term, either the x term or the constant, you can either do it by factoring out greatest common factor if it's missing the constant, or like this, that way. Okay, you guys, this assignment's going to be due on Tuesday next week. Now listen, I am going to review for the test Friday. Do not miss Friday, because that would be a terrible day to miss.